prepare you for the quiz on 11.1 through 11.3. It's on page 743. All right, the first problem says the height of parallelogram ABCD is 3 times its base, and its area is 108 square feet. Find the base and the height. So what you're going to start with is your area equation or formula. The area of a parallelogram is base times height. Now we have to figure out from the problem what is the base and what is the height. It says the height of ABCD is 3 times its base. Since we're defining the height in terms of the base, the first thing we have to say is what is the base? Well, we don't know, so we're going to call it x. What is the height in terms of the base? It says it's 3 times the base, so that would be 3x. So now we can go to our formula and we substitute in x for the base and 3 times x for the height. Now, because we know what the area is already, we can replace the area of the parallelogram side with its 108 square feet. Okay, now I can bring this in a little closer for you so you can see what we're doing. All right, so x times 3x is 3x squared, and 108 feet squared. Divide both sides by 3, and we get 108 divided by 3 is 36 x squared. So we take the square root of both sides, we get x is equal to 6. Okay, so it says find the base and the height. So x over here is the base, which is 6. And 3 times 6 would be the height, which is 18 feet. Okay, moving on to number 2. Find the area of the figure. Now there are 2 ways that you can do this. One way is that you can look at this as a rectangle and a triangle. The other way is for you to look at it as a trapezoid. If you turn this thing on its side, it's going to look like this. We don't know the base, but we know that the top of it right here is 6. We know that that slanty part right there is 13. And we know that this part is 12, and that these are all square, even though the way I've drawn them is not square. Okay, so we'll do it both ways. How about that? All right, we don't know what the base is. We've got to find out what the base is. Any way we do this, we've got to find out what this last little piece is right here. So we're always looking for some way to use the Pythagorean theorem because that works out so well for us. So I've drawn in the height of that triangle, and I have relabeled it 12 because it's directly across from an equal segment, which is 12. And this is our hypotenuse. It is not our height. We don't lean up against a wall to test our height. And you have to keep that in mind because that's a leaning segment. You can't use that. All right, now we're going to do a squared plus b squared equals c squared. Okay, now c squared then is a hypotenuse, which is right across from the right angle. So that's 13 squared, or 169. And then b squared is, we'll just call it b squared, and then we'll do 12 squared here. All right, 12 squared is 144. And when you subtract 144 from 169, you get 5 and 25 is b squared. So this last segment then has got to be 5. That's b squared, so b is 5. All right, so now we can use the formula for a trapezoid, which is the area of a trapezoid is 1/2 the bases added together times the height. So 1/2 the bases added together is 11 and 6, which is 17, times the height, which is 12. Now I like to do the canceling thing, but you're welcome just to do 1/2, which you know to be 0.5. You could use 0.5, or you could say 1 divided by 2, and you'll get 0.5. 0.5 times 17 times 12 gives us syntax error, because I hit times twice. 102. and that's 102 units squared. Okay, that's a pretty quick way to do it. The other thing we can do is use the Pythagorean theorem again to find that this is 5, and we know that this is 6, and we can just say the area of the rectangle, which is 6 times 12, or base times height, which is 72, and then we can do, and that's the area of the rectangle, and then we can add to that the area of the triangle, which is 1/2 base times height, which in this case is 1/2, the base here is 12, and the height is 5. So that would be 6 times 5, or 30. So when you add 72 and 30, you get 102. All right, you're going to have to use that formula again for the area of the trapezoid on number 3. Okay, remember that the area of a trapezoid is equal to 1/2, the bases added together, times the height. Now this one's a really easy one to do. 1/2, the bases added together, is 6.5 plus 3 times the height, which is 4. 6.5 plus 3 is going to give you 9.5 times 4 and half. Half of 4 is 2, so you could say 2 times 9.5, which would give you 19. Or you can just punch it into your calculator, and you're going to get 19. 19 units squared. Here we have a kite. There we go. Here we have a kite, and the area of a kite, remember, let me draw a kite here, is equal to 1/2 diameter 1 times diameter 2. Okay, now we know that since it's a kite, we know that this diagonal is bisecting this one. So these are equal to each other, which makes that one 4, which makes the whole thing 8. And the whole other diameter is 13. So 1/2 times 4 times 13. I like to cancel like this. Ooh, not 8. Not 4. 8. Oops. Okay, and I like to do my canceling. 4 times 13 is 52 units squared. Okay, you should have most of these formulas, the ones that are theorems, should be on your theorem list. You can't put anything that's not a theorem on your theorem list. Okay, moving on to the next one. The ratio of the lengths of corresponding sides of two similar heptagons is 7 to 20. Find the ratio of their perimeters and their areas. Now remember, the ratios of the sides perimeter, altitudes, and special segments. Special segments. Of similar figures is equal. Okay, special segments are things like mid-segments, those kinds of things. Okay, the ratios are equal. Now, the ratio of the area is equal to the ratio of the perimeter squared. Okay, so we have the ratio of the sides. It says it's 7 to 20. That means the ratio of the perimeter is also 7 to 20. Now, if you need to write this as a fraction for it to compute with you, you can do that. The ratio of the area then equals 7/8 over 20 squared, which is 49 over 400. Since 49 is only divisible by 7 and 400 is not, we cannot reduce that ratio. So the ratio of the areas is equal to 49 to 400. All right, in triangles PQR and XYZ, they're similar. The area of PQR is 1,200 square feet. Now this is area, and the area of XYZ is 48 square feet. Okay, so the ratios then, the ratio of the area would be 1,200 to 48. That's the ratio of the areas. Now, to find the ratio of the perimeter then, since we square the ratio of the perimeter to get the ratio of the area, to find the ratio of the perimeter, we need to take the square root. But before we do that, we want to reduce this into lowest terms to make it easier to take a square root. The first thing I notice about these is I know 48 is divisible by 12 and 1,200 is as well. So I'm going to reduce this to 100 over 4 since 48 divided by 12 is 4. And I immediately recognize that this is 4 times 25 since there are 4 quarters in a dollar. So I have 25 to 1 is the ratio of the area. Now I need to take the square root of that. Square root of that is going to give us the square root of 25, which is 5, over the square root of 1, which is just 1. So the ratio of their sides and the perimeters and all the special segments is 5 to 1. Okay, now it says that one of the segments is 50 feet. So what's the other one? All right, we know the 50-foot one is the PQ, which goes with the bigger one. So we're going to write our ratio and make this a proportion. We know that the side length is 50 feet, and we're looking for XY. 5XY equals 1 times 50. Divide both sides by 5. You may have already noticed that XY has to be 10. Okay, these are some examples of some kinds of problems that you will have on the quiz.